this example, we're going to solve a couple of different proportions. The first one we have is 10 over the quantity y minus 1 equal to 16 over the quantity y plus 2. So starting with that original proportion, we're going to look at these denominators. And so on the left I have y minus 1 and on the right I have y plus 2. So I'll need to multiply each side of this proportion by y minus 1 and y plus 2. And when I do that, because I've multiplied each side by y minus 1 and y plus 2, y minus 1 will cancel on this left side, and y plus 2 will cancel on the right side. So that's going to leave me with the quantity y plus 2 times 10 equal to the 16 times that quantity y minus 1. So now I have a linear equation, and I'll distribute. So I'll distribute 10 across y plus 2. So I'll have 10y plus 20 on the left, and on the right I'll have 16y minus 16. Now I want to get all terms containing y on one side and all constant terms on the other. To do that, I'm going to subtract 10y from each side. So I'll have 20 equal to 6y minus 16. And then I'll add 16 to each side to get all constant terms on the left side. So adding 16 to each side, I'm going to get 36 equal to 6y. And then as a last step, I'll divide each side by 6, so that'll give me 6 equals y. The next thing that I want to do is check this real quick. So I'll check it by replacing y every instance that I see with 6. So I'm going to have 10 over 6 minus 1. And I'm checking, does that equal 16 over 6 plus 2? So on this left side, that's going to be 10 over 5, which is 2. And on the right side, that'll be 16 over 8, which is also 2. So I've checked that answer. And now I can state my solution set. So the solution to that equation was the number 6. So I'll state 6 in a pair of curly brackets for my solution set. In this next example, I have the quantity x plus 3 over 4, and that's equal to 7/12. So looking at the LCD here, I have 4 and 12, and 4 is actually a factor of 12. So the LCD will simply be the number 12. So starting with this equation, I'll write it out. X plus 3 over 4 equal to 7/12. And then in my next step, I'm going to multiply each side by 12. So I'll have 12 times the quantity x plus 3 over 4 equal to 12 times 7/12. And from there, on this left side, 12 and 4 will cancel down to a 3. So I'll have 3 times the quantity x plus 3. And on the right side, I'll just have 7. Distributing that 3 across now, so that I can get closer to solving for x, I'll have 3x plus 9. And that's still equal to 7. Now I want to isolate that 3x, and to do so I'll subtract 9 from each side, which will give me 3x equal to negative 2 on the right. I'll have 7 minus 9, which will give me negative 2. And then as a last step, I'll divide each side by 3, and that'll make the value of x negative 2/3. So I'll go in and check that answer. I'll replace x with negative 2/3. So I'm going to have negative 2/3 plus 3 over 4, and I'm checking, does that equal 7/12? So simplifying that left side, I can go through and do the fraction arithmetic. Another option, I could throw it into a calculator. And when I do that, I'm going to get on this left side 0.58 with a 3 repeating. And when I plug in 7/12, I'm going to get exactly the same thing, 0.583 repeating. If I hadn't done that, I could have made negative 2/3 plus 3, turned that 3 into 9/3, and then continued simplifying that fraction. That would have been a right option to do it by hand. So I've checked, and that will make my solution set. The set containing negative 2/3.